What website are you talking about, Professor?
Yeah, I have Canvas, but
Canvas.
uh,
Canvas.
Yeah, because
There's
because things are sort listed there. I mean, this is not today. That was there. It's called Chapter One Notes. Okay. Now let's see what we can do. Okay. Now, um, so last week we talked about the registers. Now we going into the instructions. The basic instruction assembly is move, and add and subbar have a similar format. So we're going to look at them now. Okay, it is format is like this: move parentheses, syntax like this from to. So that means this from moves to the to. Okay. Now this is conceptually it is like a real assembly, but syntactically is slightly different. But we don't worry about that one. We're using only this compiler. So for example, in real assembly, there is no parentheses, for example. So that move means to equal from. First parameter is copied to second parameter. And it is a move, actually is copy in action. Name is called move is copy. In real life, when you move something, it is not in all place. But this is software. So move means the old one still is whatever it was before the move. So therefore, think of move like a copying. Okay. Now we are going to talk about the register to register, register to memory, and memory to register, and constant to register, and constant to memory. And we don't have memory to memory operations because assembly is simple. Memory to memory is difficult to do, but register to register, memory to register, and conversely is easy. Okay, because each time you go to memory, you have to have an address, and that makes it more complex. Here's an example of assembly. When you say x equals y, in assembly, you have to say move y to register, and then move from that register to x. When you say x equals 102 constant, you say move 102 to x. So you cannot have in real assembly, in C, you cannot have like a 102 equals x, but therefore in assembly you cannot do it either. Okay. Here's the conditions. Um, both operands must be 8-bit or 16-bit or 32 bits. So you cannot move from 8 to 16, 16 to 8. Each two sides must be the same. So you can say move EX, AX to BX, but you cannot say move AX to BL. You can't do that. You cannot do that. So that means the size of the memory variable and register must be same for two operands. Okay, except for the constant, you can move constant to 8 bits, 16 bits, or 32 bits. Because unless you have overflow, all of them works. If there is overflow, that's the error. But without that, you can move, for example, let's say 5. You can move 5 to AL. You can move 5 to AX. You can move 5 to EAX. All registers. However, if you move like 4 billion, 2 billion to AL, that will be overflow. And I I know AL, HLA is going to catch you on that one, but assembly may just raise the overflow flag. Okay. Now, example, so even though you cannot move 8 to 16 bit, but you can actually, there's a lot of trick you can use. Let's use, you want to move MA. M stands, by the way, for this class, M stands for memory variable basically. Memory variable or variable. Variable is memory variable, okay? So they are the same thing. Variable is only exists in memory, not in CPU, not in storage. So therefore, in this book refers them to memory variable as opposed to register, or you just can say also variable. So M means memory, R means register. And the number after that, how many bits is that? So you can declare, register is not up to you, they are fixed. 16 version, 8 or 32-bit version, and also they have name, AX, PX, etc. But memory variables, you have to declare it. We see example a little bit later. And also, you can have it whichever bit you want it. So in this context, so therefore M means memory, R means register. Okay, now, so here's the, even they cannot move 16 to 8 to 16 or etc. But you can actually always have do this one with a little trick. That's what always programmers do. Always they use tricks. By trick, I mean like some technique, so to do the problems, even though it's not directly available. That's what programming is. You have to be creative. Now, let's say I want to move from 8 to 16-bit. And I have to specify when I do this one now. Okay, let's say M8 is, let's say, as memory variable, and AX is the AX register. So you move 0 to AX, initialize it, and then you move M8 to AL. This is legal, same size. And this automatically moves M8 to AX. Why? Okay, first of all, sorry for that one. Anytime you change AL, also changing AX. Okay. So that is given. So therefore, when you copy to AL, you copy to AX too. However, when using AL, using the lower 8 bits of the register. This part, for example. Now, and when you copy here, these 8 bits, 0 to 7, you're copying to AX as well. The only difference is that what is going to have AH? Okay, if AH is all 0, then AL and AX are the same. So for that reason, you initialize AX to 0, then you move M8 to AL. In effect, you're moving M8 to AX. So let's explain this one. Okay, yeah, we have to assume some value. Okay, assume M8 is in binary. By the way, in text, in this book, we use binary like this. 4 bits underscore and another 4 bits. It is for reading clarity. It's not part of assembly requirement, but it is actually HLA things. And everybody does this one. even they put a space between them because you don't want to list like 8-bit binary numbers or 16-bit or 32-bit, and then you have to look more so carefully, see what is what. If you separate into four bits, you can read easily. Also, in next week, we are going to see that every 4-bit is one hex number. And that is another benefit of using this fashion. Some books use space between them, but this one, HLA book, uses underscore between them. Okay, assume M8 is this number. Okay, and then you put 0 to AX. That means AX gets this 16 bits. And when you move M8 to AL, the higher 8 bits are not affected. The lower 8 bits, they get the number you want to have, red number. Therefore, you move M8 to AX. Okay, now why we need to set AX to 0? Because we have, so AX and AL are equal if this 8 bits is 0. Okay, high 8 bits. So that's why we initialize to 0 to make sure that's 0, and then therefore, you know, we do the thing we wanted. Okay. Now let's go see some other examples. Okay, let's see example. Okay, in high-level languages, we don't do this. We just do this one because high-level languages has compiler between us and the computer, and compiler takes care of all these things. So that gives you a lot of flexibility. Assembly is more rigid. You have to follow the computer architecture. Yeah, so therefore, that's why these restrictions come into action. Now, example 2, how to move 32 to 16-bit. You just do like this. However, there is a possibility of, okay, actually, let me not cover this one, go back later that one. Let me go to real things, okay, a little bit. Shouldn't be there anyway, too soon. Now, let's do add instruction. Add instruction is the same format as move, except has the following meaning. When you say add y to x, means that x equals x plus y. You're adding to it. Okay. Similarly, we have subtract instruction, works in identical pattern, but it is subtract. Now I'm going to see some examples here, some examples from the book, and let's see, you know, to understand this better. Okay. How do you do this one in assembly? You see that you load, you move. By the way, some assemblies call move load. Okay. Now you move y to x. Then you add z to x. Then you add t to x. Therefore, these 3 instructions are the same as this one instruction here. Your assembly is simpler, therefore one instruction in high-level language can be more than one instruction. Could be as many as maybe 10 or more, because in high-level language, we have such a flexibility. You know, we have a long expression. You know, in assembly, we have to follow each instruction, one simple instruction at a time. Okay, how about this one now? So there, by the way, for this one, there is more than one way, but we try to choose the one which is the shortest one. Now, if I begin from B, that will be some longer. So let's move from inside parentheses, namely move D to AX. And you want to double it. You're going to see next chapter, chapter 2, when you can double it by so-called shifting. But that's later. But for now, by the way, we have to assume only the thing that we know so far. You cannot use materials from other chapters yet. That's the learning process. Now, so we move D to AX. Now, AX contains D now. Then have to double it, move AX to BX, and then add BX to AX. These three instructions correspond to doubling to D. Now, then you add C to it. Okay, that takes up parentheses. Then you multiply by 2 again, like before. You move AX to BX, and you add BX to AX. 5 and 6 are equivalent doubling of these things, 2 times that one. And finally, you add B to AX. Okay, but we have not finished yet. At instruction 7, you've done the calculation, but you are not in memory. You are in registers. You have to complete this one by moving from register to memory, to variable. So that completes that one. Okay, how many instructions for this one? 8 instructions for one. Again, there could be other alternatives, but this is probably the shortest one. Okay, how about doing this one in assembly? Okay. Now, let me do this one a little bit later because I don't want to overwhelm with this one yet. And actually, I do this one in computer and show you how it works really. Okay, later on an exercise. Okay, variables. HLA allows to have variables. Actually, HLA is basically assembly, but except has it's more versatile. Has more features than assembly does, and is more concise. And HLA is created by some person who wrote the book. Therefore, you should use HLA compiler to convert assembly. So if you read other books, they don't know HLA. HLA is only this book, but assembly is general. If assembly assembler is called MASM, MASM, Microsoft Assembly. However, we don't use MASM here, and you cannot use HLA and MASM together. Why? HLA syntax is different from MASM from the beginning. Conceptually, they are same, very close, but the syntax is different. For example, MASM does not use parentheses on instruction like this here. And also switches the operand. Therefore, you cannot mix MASM with the HLA. Okay, you have to follow HLA 100%. Some students I have seen trying to use the exercise and MASM. No, you should use HLA, and you cannot mix them. You have to use either MASM, which we don't cover it in this class, or use HLA. Why we not cover MASM from the beginning? Okay, that will be too difficult. Among other things, which you're going to read in a moment, it doesn't have control structures, MASM. They are done differently. So therefore, every assembly learning book has some stuff built on top of real assembly. Some people have using MASM syntax, and they create few functions, and then the rest of it is MASM. Now, one thing that every assembly needs is input-output functions. And it is very difficult and tedious to write them yourself. So every assembly language You must have those input output. But the other important thing is control structures, while loop, if loop, those things. Now, we are not using the assembly version of them until chapter 7. We gradually introduce more assembly, real assembly, but on chapter 7, we almost take care of all things. Again, I said almost, not all of them. Why? Because inherently, syntax of HLA and assembly are different. Concept is the same, but the syntax is different. And why? You know, anyway, he did that. That means the other did that way. So maybe I would have done differently, but it is different syntax. That therefore we never get rid of HLA. But by end of chapter 7, we get a lot of assembly anyway. And after all, nowadays, not by people writing assembly. It's only for understanding computer better and also understanding. Also, it is requirement for you passing to other colleges, universities. Now, there could be somebody using an assembly language directly. If you have a device, hardware device built, like let's say computerized, automated sprinkler system, you know. So that doesn't have a nice compiler like C or editors. They can afford to do those kind of things. However, that already has machine language, assembly language built into it, and they can do it in assembly. Therefore, it is assembly could be useful sometime, even in practice. How about machine language? Oh, machine language is too cumbersome. Everybody, I don't know anybody using that in real life now, because it is so difficult to use, so easy to make mistake. Just 1, 0. If you make 1, 0, want to be something supposed to be 1 to be 0, then the entire thing would be incorrect. Now, before moving to variable and HLA variable are so-called case neutral. It is okay. It is like case sensitive, except that uppercase. Once you have uppercase or lowercase of something, you cannot have the other case in HLA. So case sensitive, which is used in C and Java, etc., means that capital A and lowercase a are different, and you can use both of them on the same program, on the same spot. So, for example, you have ABC, you can use ABC all lowercase, ABC all uppercase, capitalize A, capitalize B, and all combinations. In C Java, you have you can build so many varieties of the same spelling. Not here. Here says, okay, once you use ABC, uppercase or lowercase, you cannot use any version of that one. However, if you use ABC uppercase, declare uppercase, then you have to use rest of the program like that. You cannot declare ABC to uppercase and use in the program lowercase version of it. It must be uppercase. Or let's say using ABC A capital, BC lowercase. Then you have to use the entire of the program like that. Therefore, for all practical purposes, assume HLA is case sensitive, except that you don't have the thing that you want to use the same spelling on the same program with different cases. Clear this part? What does the case neutral means? Okay. If you have, please ask a question. Okay, we're going to look at the control structures. If you're coming from Civil, Java world, or even Python, these are very easy, and C is requirement for this class. Anyway, I will go them slowly over them so we can understand them. Before we begin, we have to define so-called relational operators. Now, again, this is HLA, okay? In assembly, you will see that one relation operators are differently handled, chapter 7, 6 and 7. Now, so if you know C, you know relation operators. There are 6 of them: equality, non-equality, less than or equal, greater than or greater than equal. Or now, students always might be confusing with this one. There are 2 symbols for some of them, like less than or equal, greater than equal. First of all, you should not leave a space between them. Secondly, always equal comes last. So you don't have to memorize this one. In all situation and in other places, and there is a 2 symbols for operator. The equal, one of them to equal comes last. Some other thing that some of them might have from high school, maybe have it, you still have it now. Try memorize which is bigger, which is larger. Very simple. The one inside angle is larger than the one in outside angle. So you don't have to memorize which way. Okay. Also, you can read it in different way. A is less than B is the same as B greater than A. Okay. Now, okay. However, don't confuse with the opposite. A less than B is the same as B greater than A. However, what is the opposite of less than? People say greater than. No. Opposite of less than is greater than or equal. Okay. Now, let's move on the control structures. So we use relational operator to compare 2 quantities, and that gives us yes, no. Either they are the relation holds or it doesn't. So you get either true or false. It is very, very binary. You cannot have anything else. Relation operator always gives you true or false. No approximation here. No doubt here. You get either true or false. And that is used in if statement, and we don't have all variety, and we have the all variety as if that we have in C. Namely, if only, if else, and then if else if, and then nested if inside if. All of them available in C, we have it here too. Okay, now the only syntax is slightly different. Here we have, in addition to other language, we have word then, which we don't have it in C. And so this part is identical, but then is extra. Okay, don't forget to put in. And also we have end if, like this one. Okay, so it works like that. If condition within parentheses, then keyword then statements, and then you might have else if expression, and then and continue. You can have many level you want it. Okay. Now I'm not sure these are uppercase or lowercase. Anyway, use lowercase. Okay. Now in C we have braces. We can have that one here too. No, actually we don't need them here. Sorry, I misspoke. Now loops. So before going any further, we have all if that support in high level language, you have it here too. Okay. Now, also, I don't remember, probably we have case too. I don't remember, look at them. I don't use case that much in this language. Okay, loops, 3 loops, while loops, repeat loops, and for loops. Okay, while loops has this syntax, while, do here, and end while here. One word, end while, end if, and it should be probably lowercase. That is the when you tap then computer become uppercase. Okay, so it should be lowercase. Now, and it works like this. You check the condition or expression first. If it is true, loop begins. Okay. When you do statements, after that you go out and check the condition again. You do it, I mean, computer does, you don't. And this happens until expression becomes false and the while stops. Okay. Like high-level languages. Now, when we do real assembly in chapter 6 and 7, you see that how we can handle the while loop with the jumps. Jump. Repeat is this. With the repeat, you begin statements. No condition check at the end, at the beginning. However, you check condition at the end. Okay, also look at the reading. You say, while this is true, do it. Repeat until this becomes true. Okay? Watch for that. Repeat says, do it until it becomes true. And the difference is that you check condition at the end. So repeat is going to be done at least once, while only could be done 0 or more times. And for loop, for is a shorthand for while, a special while. For loops works as follow. First of all, we have syntax like this, for and do here and end for. And this part is identical to C, 3 parts. Initialization is performed at the beginning of the for loop, regardless. That is done. So you think that is outside of the loop, I imagine. It is done only once at the beginning of the loop. If loop goes 10 times, you're not going to repeat initialization. Okay, after that, immediately expression, which is same as condition, expression means same as condition here, is evaluated. It gives you true or false. If it is true, you do statements after for 1 time, 1 round. And after that, you go to increment. Usually add 1 or add 2 or decrease 1. It could be either way, by the way. Up and down. It's called increment, but you can also look at the decrement. Okay. After that, expression evaluated again. And this is true, loop continues until expression becomes false. 1 more time, initialization done once. Then after that, before entering the loop, expression is evaluated. If it is true, loop enters. If it is false, you don't enter. It is possible loop, for loop is wrong from the beginning, and therefore you do none. If expression is true, you do statements. And after that, automatically you do increment. Okay, that is, if you do statements, you follow increment. And then you check the expression again, the condition again. And if it's true, continue until it becomes false. So if you want to do with this while loop, I cannot write here, this is PDF, but you can take the init out, and then you will say for expression, statements, increment, and while. Okay. Logical operators.
Professor?
Yes, go ahead.
For the for loop in the initializing area, is that like in C, or like for this in assembly, would it be the same as C where it's the counter?
Yeah, this is the logic is identical.
So it would be like I is equal to 0 for the counter, and then you would increment I plus plus.
True. Yeah.
Okay. Thank you so much.
Yeah, you'll see some examples of that in the book. Good.
The repeat and until, is this the same as the do while loop?
Okay. Yeah. Yes. Yes and no. When you enter, do while and repeat are the same. However, look at that's the meaning of each word. Do while something is true. Repeat until something becomes true. See, watch for that. Okay. See, they're kind of inverse of each other at the end. Okay.
Okay. And then we don't have to put like and repeat, right?
No, it is until. You know,
Yeah, until, yeah. We don't have
the
to,
syntax is not very consistent.
okay.
Actually, the one we use the most is do and while and for loop. Usually repeat use less often.
Okay.
Logical operator. This is like a C. That's and, that is or, and that's not. Logical operator and or are binary, means they need two operands. And or is binary, not is unary, means you need one operand, it negates that one. Okay, let's look at the C. Okay. Now, let me go switch to book and come back to one later. Okay, is that the one? Yeah. Let me read this one in the book too. Okay, give me a moment. Not this one, actually, because okay. Let me see. Instruction. Okay, this is your textbook, and it's here. So you might read this one as extra reading, you know, can understand this thing better. Okay, these are the instructions, possible instructions, possible formats. Okay, R8 with the R8, R8 with the memory 8, memory 8 with the R8. You see that number 2 and number 3, memory and register could be on either side, but both of them cannot be memory. Okay. See, this is actually, these rules are the harder rules coming from AD86. HLA some say some that you cannot put memory into memory, but we will follow this one, avoid that one. And then constant can go to register, constant can go to memory. And there are 15 of them actually. These 3 are repeated for 16 bits, this 5, I'm sorry, and another 32 bit. So it is just the same concept for the different number of bits. That means you can use these operands together. Register with register, register with memory, memory with register, constant to register, constant to memory, 8-bit version, 16-bit version, and 32-bit version. Okay. And as you see here, add and subtract has the same format as move does. And it explains here what I just said. And here's the example. Okay. For that, before the class, actually, let me see. Okay, let me go over the book and then come back to the example. So I like to review book 2. Okay, I tell you which one, don't worry. Don't worry about this part. This is page 18, these things, you know. HLA is overkill sometimes. But this is the one we just discussed, the relation operators. There are 6 of them. Relation operators, the CPU has a component called ALU, it stands for arithmetic logic unit. So arithmetic is obvious, arithmetic operation. Logic means basically comparison, relation operators. Okay, that's logic means that basically. It is so important that it is in the heart of CPU. Because without that, you cannot do loops, you cannot do selections. And if you don't do those things, programming is nothing, basically. You cannot write much without controlling the flow of the program. Okay, these are examples of HLA variable. Okay, don't worry about the first one, but then all of them, I believe, legal stuff. So first one is variable name, second one is register name, return register name, then you're comparing register against register, you're comparing register against number, you're comparing memory against number, you're comparing register against number, and so on. And this is, we don't use this one, okay, and don't worry about this one. That's we don't need to, that much. Here's the if structure. You can have if expression means like a condition, A equals B, A greater than B, A greater than B plus C, something like that. Now, then you have a bunch of statements here. You don't need braces because else if is going to cover it. And if you don't have else if, eventually you're going to have end if anyway. So end if is there, the first part is there, and middle one, depending on situation, might be there or not. You can have else if many levels. And else is also optional, is like high-level languages. This has the same meaning as the high-level languages, okay. So this is like an expression comparing EX against 0, and then you do this one. Okay, except that HLA also using equal for comparison. In other languages, equal only used for assignment.
Professor,
Yes.
just another question. On the left side of not equal, what is that sign for? The less than, greater than, together?
Oh, this one?
Uh-huh.
Oh, that's actually another notation, means not equal.
Not equal?
Yeah. This means, this is Pascal notation, not equal.
Okay.
You know, that's, but we use this symbol, not equal like that, and that one for equality, and these are the same, 4 of them. Okay, this is an example of if-else statement. This example of if and else. If, else, if, else, if, else, if. You know, this can go for many levels. That could be like sometime 10 level, no things. This actually basically means and, or, etc. Okay. And let me go to tables. There should be tables there. Actually, no, I just explained in text. So we have and symbol like this, and or like bar, and see the table here down somewhere. No. Okay, these are means basically and or and not, essentially. So don't this is a little bit on new words, but that means basically and or and not. Now we have 3 set of operators: arithmetic, logical, arithmetic, relational, and logical. You can combine them, and arithmetic operation are done first. Then you do relational, then you do logical. And within the logical, you do not first, then and, then or. Then arithmetic, you know, that you do multiplication, division first, and you do addition, subtraction. Anyway, but you can combine them. So this actually has, this is a relation operator, put the and together. These are designed in a way actually make sense, you know, mathematically or even non-technically speaking. Okay, now you can have and to be more than 2 combination. You can go and, you can go many of them. And this is or. Here the example of or. Look, you compare this, then you compare this, you or them, then you do this negation, then you OR them. If you want to do a different order, what? You do parentheses. Parentheses make one thing to be, I say atomic, means makes many things to be one. And because of that, you have to evaluate parentheses first, because parentheses makes expression to be one thing, basically. So you have to consider entire parentheses against other one. Therefore, you have to do inside parentheses first. Okay, and this actually is kind of, you obtain this from doing math. Okay, this while loop we discussed. Okay, and then this is another while example, for example. And this one, for, and that while are equivalent. In fact, for is a shorthand for a particular kind of while. Okay, see here, initial part is done before the loop. Oops, I don't want to highlight the second line. And then this one is evaluated here and here in the same time, same order, okay? Means after once for enters, you initially evaluate that one. If that is true, you do this. Here you do that. In for loop, after doing body loop body, you do this one. If you want to with the for while statement, you have to put that one here in that order. That must come at the end of the for loop, while loop. So this while loop and for loop are equivalent. Okay. Anyway, for loop is very useful, very good shorthand for so many good things, because you do a lot of things like with the for loop. Okay. Now, in assembly version, we would like something like this. You can, you know, since we don't have like equal thing, you have to like, this is like a I equal to 0. Okay, this is like high level language, and this is like I equals I plus 1. Okay, you see that one, how for loops has the same structure, but inside of it is slightly different. It is different because you have the assembly language whenever it's
Professor, what is MOV?
Move.
Move?
Move means copy, basically. I equals 0. That means I equals 0. Move. Okay, that's what we began discussing today. Move. Very.
It's like a public function, right? Like.
Yeah, the assembly statement. Yeah.
Okay.
Move. Add. Sub. Okay, this is repeat. Okay, don't worry about break and those things. That's a little too much for now. We don't want to go that far. And don't worry about this anything from here until try and things. This is unnecessary here because our focus is not different. Also, don't worry about this stuff all the way to. Okay, this one actually we discussed last time, using library to input output. But you need this one for all practical purposes, not like for question. You know, I'm not going to ask question, what does this function does, that function does. Okay. I'm sorry, this is actually different function. Okay, don't worry about that word. I thought that is actually input output functions. Okay. So don't worry about that one until in standard IO, until here. These things. Again, I summarize all of them in my notes at the end of beginning of the table. Okay. Again, this is therefore you only learn from here on from, let me go back all the way to the one we began. It's page 18. '17. So this actually one I basically did only 2 pages here. And Boolean expression. Okay, don't worry about the flag, these things. This you can skip this one. These are operators, relation operators. And again, these are, don't worry. And then we go to control structures. And go. These are examples, basically. Examples. It's not that much things, okay, until here. There's, after this one, not much to be responsible, except the I/O functions, which you use them when you need them in exercises. In question, I might use them, because I might ask, what does this program do? Then I have to use I/O functions, but that's it. Okay, let's see. I said 8 is going to be a quiz now. Okay. Let me see. Okay, it's only 5 minutes left. Okay, I have a few examples I cover after the break. So I'm going to let you take quiz between 8 and 8:30. And after 8:30, we begin and we look at the exercises and we do some of them ourselves, okay? Now, back to notes. Let's see review of my notes one more time before, because we have a few minutes time. I'm going back to okay. Okay, it begins from here.
Professor, I have a question.
Go ahead.
Where is the quiz happening? Is it on Canvas?
Yeah, I will be in Canvas. You see, the quiz will be available. I would make it. I publicize in a moment, really in 1 or 2 minutes.
Okay, thank you.
Okay, sure. Okay, I find that this example 1 and example 2 are a bit too much to discuss at this time. Just ignore them for now. Here, these things, because it might be confusing at this time. Shouldn't be there. They are kind of introduced too soon. Okay. Now, let me go to Canvas now. Okay, those students who were coming first time, take this quiz as much as you can, and don't worry, because one, you might not do well. However, you have like 15 minutes, and go and look at the registers as much as you can. And if you don't do well on this quiz, it's only one quiz, and you have chances to compensate for that. Okay. Now, hold on. Let me go back to Canvas now.
So Professor, with the quiz, like, how will it be formatted? Is it something that we'll have to like type out what the answer is, like after we see what the source code is, like what the output should be, or?
I will show you now.
Okay.
Let me find the things. Actually, let me switch the. Not this one, not this one. Okay. Not this one. I'm trying to find the window. You see a small version of that one. It's a bit difficult to see. Okay, here we go. Not this one though. Okay, we go back to the modules. You don't see it now, but you will see quiz 1 become available in a moment. But before that, let me show you what kind of, how my quiz look like, mostly. Okay, the quiz one, yeah. My quiz look like filling questions, but easy filling questions. You know, you within limited number of stuff. Choose many answers you want. Again, this is filling, but you have to go into these 3 words and multiple choice. Okay, so it will be look like that. So, for example, and I give you example to help you. So, what I want here, I want a number. What is the size of a edge register? You know. So, let's read that one carefully. Canvas. This is graded by Canvas. Therefore, you have to be careful on the format as well. For example, if 2 is answer, 2.0 is that answer. Because Canvas sees them as a string, as text. It doesn't understand 2 and 2.0 are close. Okay, in filling question, not I might give you 10 answers, but you might use 2 of them. And you might use one of them repeated. So it's not like one-to-one. Canvas is not case sensitive. Don't worry about that part. Okay, answer to question will be available after everybody taking the class. So please, if you miss it, don't answer what I did correctly. Why is it like that? Wait until you see the real answer, and most of the time you will see what the error was. And you have 15 minutes and 1 attempt and no makeup. Okay, so let me assign it to you now. Okay, you should see the quiz 1 now and begin taking it.